my name is Tomáš Zeman. I'm a smart TV and website team leader in Showmax. And today I'll be talking not only about remote testing of applications on smart TVs, but about our journey from the usual ways of testing to the remote. So before I get to the topic, I'd like to briefly, for those who haven't heard about Showmax before, I will just briefly describe who we are, what we do. So we are a video streaming company. We are mostly or currently focused only on African market. Our biggest customers are located in South Africa, Nigeria, and Kenya. And as you can imagine, these countries, not all of them have developed their infrastructure, especially when it comes to the internet or mobile connection. So this is a challenge that we tackle every day. Basically, we have to challenge ourselves to produce a service and create services that are fast, efficient, and are able to work on such low infrastructure and also with devices, because not all the time these people don't have the high-end mobile phones. They usually have old Android phones and stuff like that. Of course, as other streaming services, we support a wide range of devices. So starting from website, smart TVs, mobile phones, as I said, to even set-top boxes and gaming consoles. Oh, sorry. What makes us unique, I would say, is the content that we have. We have a blend of Hollywood content. Also, we stream live sports. So currently, we have Premier League, or recently we streamed the Olympics in Tokyo. And we also produce our own content. So we have teams that creating our own TV shows, and luckily they won a lot of awards. So they are quite popular in South African countries around. And now enough about us, and let's get to the topic we all waited for. I have some issues with this. Oh, it's working. Cool. So the testing on smart TVs, or the testing of applications on smart TVs, hadn't changed for many years for us. We had a big TV wall with dozens of TVs in the office. The number of TVs expanded basically every year because we support many brands, and for each of the brand, you need a low-end device, high-end device to ensure that the customers have the best possible service, because these devices don't behave the same really. And you had to be obviously present in the office in order to test these devices. This worked for us for many years perfectly, until, of course, the situation that happened 2 years ago when the COVID pandemic started. And when that happened, our management took an immediate and responsible decision that we have to move to home office immediately to protect our health, protect health of our friends and families. And this was something that we really haven't been prepared for, and couldn't be, right? It's not something that happens every day. So we had to improvise. So what we did back then is that we took some of the TVs. Well, we tried to mix them, so we have the major combinations, the most important TVs, and we took them home. But you can imagine that if you have a small apartment having 40, 50-inch screen at home, twice, 4 times, even some of the guys had 4 TVs. It's not ideal, and it's not ideal even if you have 1 TV on the ground and you have curious kids, right? So it was we knew back then that it's not a solution that can stay with us for a long time, basically. So what did we do about it? I have to say that because we kind of like, or maybe love experimenting, we really weren't afraid to try something new to get the job done. So we decided immediately that we want to create some solution, and we didn't create it immediately because we kind of expected that the pandemic won't be with us for 2 years, but we expected that it will maybe end in a couple of months. Who knew, right? So after that it seemed kind of hopeless. We decided that the remote way of testing is the only choice for us. And how did we approach it? Fortunately for us, even before the pandemic, we had an end-to-end solution for our TVs. We were able to remote, well, not remotely, but we were able to test the TVs automatically. We had a solution made by Sweetest. It's a company located in Prague, and they create a device called CandyBox, which is and I will get to it later on with more detail, but it allows you to control the TVs remotely or via some API. So we took that as a basic or the ground, and then we put IP cameras on top of it and created some networking to ensure proper security and speed. And just a second. So this is a high-level architecture of how it looks like right now. So imagine you're a tester at home and you'd like to test some feature. So what do? You pick your IP camera that you want or that is currently free. You rotate it or point it at a TV that you want to test, or you want to test the app on. And once you're happy, you're zoomed in, you can see all the details that you need. Then you can move to the CandyBox. You connect to the CandyBox, and you can start controlling the TV from your home, from your computer. You obviously control the CandyBox over the network from over the internet, but the CandyBox is sitting below the TVs in the office and is connected to each of them by a cable infrared transmitter, which is something that I will show you in a moment. So this is how the CandyBox really looks like. It's a 20-30 centimeter tall tower, and it's basically some sort of Raspberry Pi computer with some Ethernet cards. You can, on the image, you can see 5 of them, I think. So currently, this device has around 40 Ethernet ports, and every single port is connected to the infrared blaster, which is the leftmost image, and this is the thing that produces the infrared signal to the TVs. So it's like controlling it with your remote control as usual, but you can use a virtual remote control either on your phone or in website. One huge advantage, or maybe 2 huge advantages of this device are that the blaster itself, the hemisphere or the white ball in the end is semi-transparent. So even though it's glued on the receiver of the TV, you can still use a remote control in case you're in the office, so it doesn't block your signal from the outside. And the other thing is that you can really glue it anywhere, and it doesn't even have to be a TV. It can be any device that receives an infrared signal, and you can teach it to produce any signal you want if it can be controlled by the infrared. So basically, the possibilities of the devices are endless. It doesn't have to be just a smart TV. And just a side note that while we were in the office and using the remote controls, obviously, if you point your remote control on the TV wall and you push the button, it controls all the TVs at once, right? So it's not perfect that you have 4 testers in the office, everybody's trying to test their own thing, and suddenly somebody turns off your TV. So what we did, and I hope it's visible on the image, but we designed our own adapters on the remote controls that are basically directing the infrared signal as like a laser, let's say laser beam, and it's 3D printed, and it fits on every remote. Like we have a special designs for every type of remote, and you can easily control the TVs without worrying to interact with other TVs in the office. Now I'd like to show you a short demo of how it really works in real life. Hopefully it will run nice. So this is a view from camera that is mounted in the ceiling in the office. And let me start it again. It was too fast. Thanks. So this is the TV wall. And on the right side, we have some pre-configured TV locations. So you can choose your TV, click on it, and it will automatically slide on the TV that you selected for testing. And then if you have the TV in focus, you can use the remote control on the left side and start navigating through the app. So let's say I want to see if I can play Sherlock Holmes in some test case that I have. And you can also notice how fast it reacts to the remote. And this is how we basically test it, and you can see it's really usable. But the journey was not that easy. The final solution looks really nice, but in fact, no, I don't know. Nice. So there were a couple of issues along the way. So it took us several months to create a final solution that we were happy with. And one of the first issues that we encountered was the video stream resolution. So whenever you need to test some UI bugs, or you need to see some tiny text, obviously from the camera that is far from the TV, it's barely visible. So you either need a camera with a good stream resolution, and even better, a camera with optical zoom, because from our experience, digital zoom is not enough all the time. It can work on TVs that are closer, but you need a really optical zoom. But still, this was not the biggest issue we faced, and that was the network latency, unfortunately. And when we first assembled the solution, the latencies were so high that this was almost unusable. It took almost over 2 seconds to get a response from a button click, basically. So we decided to measure all the pieces of the infrastructure to see if we can find some bottleneck. And just before I get into the numbers, all the latencies that I will show you in a moment are just approximations of several measurements and just rounded, just to give you the scale, the idea of the scale. So first, we started with a VPN, because when we started, we used a third-party solution from Zero Tier, and unfortunately, their servers are not located or back then were not located in the Czech Republic. So the path that every single request had to undergo was quite long. So even just using their VPN added 300 milliseconds to the latencies. So we decided to create or spend some time creating our own solution, our own VPN configuration, and we were able to push it down to 30 milliseconds. Then we obviously measured the candy box, or the sweetest infrastructure. Unfortunately for us, this was not a problem, and partially because these guys are in Prague, their servers are here as well. So latencies here are quite stable, almost negligible. But then the biggest issues we found were with the cameras themselves. Most of the cameras are using RTSP protocol for streaming, and the cameras that we bought in the first round, they had latencies from 1 to 2 seconds, depending on the quality of the video. So 1 second was for the lowest video, which was kind of okay, but not sufficient for us, and 2 seconds were for the ideal quality. So that was really not usable. So we start digging around the cameras. We're trying to look it up. How is it that it's so slow? And we found out that most of the cameras, they don't really care about the latency, right? It's usually a surveillance stream, so you don't care. You just watch the stream, and the latency is not a big issue. There are some cameras on the market that are low latency, but they usually are either hard to get or they don't have all the capabilities like Zoom. So we thought, okay, what we're gonna do, and then we noticed that some of the cameras, they have a web interface that is running inside of the camera and is able to produce some sort of stream. And these interfaces are usually quite fast because the camera doesn't have to spend so many time encoding the stuff and sending it through the stream. And we were able to get up to 400 milliseconds. So in total, if you sum it up, VPN plus Candybox plus the camera, it gives you something around 500 milliseconds, which is usable for us. And if you try to compare it with your normal remote control that you can use on your TV, even that it's not instant. Especially if you have an older TV, there is some like the TV doesn't respond immediately, and 500 milliseconds that feels sluggish the same way. So it's certainly usable for us. And this was the solution that we were finally happy with, and this is how we ended our journey some time ago, and that's it. So for those who like this talk or would like to see more about our company or would like to even join our company because you like what we do, we have good news. We're still hiring and growing. We have the engineering based here in Prague mostly, but we're also hiring remotely. And if you live abroad, we offer even relocation. And if you'd like to know more, visit our blog. There's first of all, we have all the job offers there, and also if you're curious about more cool stuff we do, you can find it there as well. So be sure to check it. It's full of great stuff, not only by our team, but from the whole Showmax. So thank you very much.
Did you ever think like doing some kind of testing automation out of this? So you would, because at the beginning you said something like end-to-end testing, right? So is this actually working the way that you run some script and then it goes through some, tests and it shows you that it's green?
Yeah, that's basically how we started, right? We have a end-to-end test suite that run the automation, and every single change that we do has to run on these TVs to make sure that it doesn't break anything. So we already had that in place, but we didn't have the infrastructure that would allow us to do this remotely. It was all running in the offices.
How many TVs do you have? Are those TVs are like different? Because I think that any TV is kind of different, and if it's not a secret, how much was it to make this all work? Because I guess it's kind of expensive stuff. Thanks.
I don't know how. Thank you for the question. I don't know how much was it in total, because some of the TVs were secondhand. We just bought them in some bazaars, or anywhere we could get them. We were happy to get them, right? But in total, I think we have around 30 TVs now, and we usually buy 6 more TVs every single year. And like 5 years ago, it was okay because vendors still offered 30-inch TVs. But these days, like 40 is minimum, and most of the high-end ones are 50 plus, and suddenly the TV wall is not large enough.
What would you say is the hardest smart TV platform to develop for? Like, what is the Internet Explorer of your world?
It depends. I would argue that it's unfortunately Samsung, or maybe Hisense, but that's not that popular here. Maybe Hisense. I think we have currently 3 brands. It's Samsung, LG, and Hisense, which are the most common in Africa. And from these 3 brands, LG is by far the most easier to develop on. Tizen there had major bugs in the older versions. It's improving, and Hisense that feels hacky even in the newer versions, but it's improving.
What technology are you using to build UI in?
We're using TypeScript and React, and it works on most of the TVs, especially on the new ones. They have the power to run React. The older TVs, they are quite slow, and we had to make some changes to make it even like somehow work there. So we first of all we replaced some major components with vanilla JavaScript or vanilla TypeScript. We didn't use React for that, and we removed some of the animations, shadows, anything that could clutter the experience, make it slower, right? Basically. But yeah, on the newer trees, it runs totally fine.
As a developer, front-end developer, for example, we have some sort of dev tooling. So can you plug into a TV and hit some command that will give you like a debug log? Do you have that functionality in the TV?
Yes, the TVs. Well, the TVs we support, they usually run a browser environment. So the oldest TVs have some sort of WebKit. The newer ones have Chromium. So you can connect to the TVs and you can open the native DevTools, and they look similar to Chrome DevTools, only in older version. So you can do basically the same stuff, which is good because without it, I don't know how that would be possible, because pushing the changes to the TV takes some time, and testing every single change this way would take an enormous amount of time. So we're happy that these TVs have the debugger.
If it is running Chromium, you can use some Cypress or Selenium testing automated, or not?
We don't use Selenium testing. I think it could work. But if you want to run end-to-end test, even with the remote control, because that really makes a difference in some test scenarios, then you really have to use the sweetest. But the API of the sweetest is basically Selenium-like. So you push, or you do some action, click a button, and then you have some assertions that URL has changed, or you can find the element that you want, check the text and stuff like that. So it's quite similar to Selenium.
Okay, I wanted to ask one thing. So if you said that everything is on either WebKit or now Chromium, so what is the main difference between the devices? Because I thought that there was a problem with some proprietary software, or is the difference between the remote controllers or some layer above it?
It's I guess,
what makes it that
I guess the problem is in every layer that there is. So first problem is the old browser environment, because it's not either behaving like it's supposed to. There are bugs. It doesn't support new features. Another problem are the operating system themselves. They have bugs. They have playback bugs. So suddenly you get a player error, unknown error, and you don't know what to do about it. You don't get any message. So it's quite challenging to sometimes debug these issues. So it's all together. And sometimes it's even the remote, because the TVs, they don't always react to your button press, right?
Okay.
So it's all together.
Is there an outlook on some standard, or nothing is in near future?
I think it's slowly getting to it, because the newer version of Chromium they are using, the better the things are or become over time. So, and we also use a lot of polyfills, a lot of vendor prefixes for CSS styles and stuff like that. So this is something that helps us to overcome all the issues of these platforms. But obviously there are some that we can't work around this way. We have to find some hacks, some custom special changes for that.
Thank you.
More questions from the audience? Okay, then I have one of my own.
Okay.
Did you consider outsourcing this whole thing?
Yes. In the beginning, yes, because we are afraid that having too many brands at home, and also there was a chance that we're going to have more brands in a short period of time. We were considering outsourcing it, but we were kind of scared as well of sacrificing the quality because we had prior experience with. Well, I don't want to blame them, but we had prior experience with Samsung and LG QA. They are usually responsible for testing your app before it gets out to the store, and the quality was not ideal. So we are afraid that giving our application to some third party, they will just do the basic testing, and it's not going to be enough. And of course, our testers have huge experience. They know the platforms very well. They know Showmax platform very well, which is important because not all the bugs are coming from our app, but it might be a problem of the remaining platforms around it. So we decided not to do it. We didn't want to sacrifice the quality, and our testers are just too good. They can't be really replaced because the experience and over the years is just huge.
That leads me to a question from Slido, which is how many testers do you have? And do you use some kind of reservation systems for the TVs?
We currently have 4 QA members that are directly located to our team. And reservation system for our TVs, meaning, oh yeah, no, we don't have that. But so we have a Slack channel, so we ask if this camera is free or that camera is free. And then you can see if one of the TVs is turned on, then obviously somebody is using it. So we don't have that. We didn't have that many collisions currently, so we didn't really think about it so far.
Okay. What is the most painful thing about smart development? What is the best?
The most painful thing, I think, are the operating system, as I mentioned. They have unexpected bugs, and they don't usually work as expected. They don't even do what they are supposed to do based on their documentation. So that's tricky. And the best thing is that is challenging. And I mentioned that the TVs are slow, and actually that's the best thing for the developers or for us, because it makes you think about the changes in terms of performance. And it's something that you don't do every day, and you really need to look at the low-level way of rendering under React, and it makes the work much more interesting.
Challenge is the thing.
Yes, certainly.
Okay. Or platforms do you plan to support team?
Good question. Well, we already plan 2 new set-top box platforms, which we want to support in upcoming months already. And then we'll see, maybe new PlayStation, maybe new Xbox. Who knows?
How old TVs do you support? And do you also struggle with losing focus in app?
Yes. Yes, that was, or currently it's quite stable, but when we started, losing focus was one of the major problems that we had. Right? You were just playing with the TV, you press button twice in a fast manner, and suddenly your focus was lost. But I think that for last 2 years maybe, we didn't have too many problems with focus. And the first question was the oldest TV, right?
How old TVs do you support?
We support LGs from 2014 and Tysons from 2015 with our React application. We have older application that doesn't run React, and it runs on TVs from 2012. So, but
Yeah.
we still have lots of customers on these devices. It turned out that people don't want to upgrade their TVs, and they mostly using them as a large screen and connect either Apple TV or Chromecast, Android TV, and they don't necessarily need to upgrade every single year, or not even after 10 years. So.
Okay, and maybe one more question from me. What would you like to improve on your solution? Is there anything that you have in mind?
Yeah, maybe one thing. Since the TVs are not that stable, sometimes it happens that the TV gets completely stuck, and if you're remote, you can't really unplug it from the electricity, right? So we'd like to have some remote controlled power sockets, so we can turn it off, turn it on, like so. So this is what we plan to do quite soon.
Okay. So I don't see any more questions. Thank you very
Thank you.
much for your answers and for your talk.